Let's solve some equilibrium constant expressions. Write the equilibrium constant expression for the reaction of hydrogen and iodine to make hydriodic acid, all gases. That means everything's in the same phase. It's all mixed together. We don't have to omit anything. And the coefficients will become exponents, so we'll make a note of that too. And it'll be the concentrations of the products multiplied together divided by the reactants. Therefore, the equilibrium constant is equal to the concentration of hydriodic acid squared divided by the concentrations in moles per liter. That's what the square brackets mean, of hydrogen times iodine. If you know those concentrations, you got yourself an equilibrium constant. For this one, the reaction of iron 2 oxide with carbon monoxide, the things that are in solution are the carbon monoxide and the carbon dioxide. The other things are not in solution, so they get omitted. It's simply the equilibrium constant is simply equal to the concentration of carbon dioxide divided by carbon monoxide. Notice no special coefficients, and that's it. Let's go ahead and solve one. Okay, we've got hydrogen sulfide decomposing into hydrogen plus sulfur with a very low equilibrium constant. That means mostly it's going to be starting material. It's not decomposing much. But we can go ahead and, if we're given enough information, and they did give us 2 of the 3, we can figure out the concentration of hydrogen. This turns out to be simply a math problem. First, write the equilibrium constant expression. It should be this times that, where the H2 gets squared and the H2S gets squared. Everything's in solution since it's all gases. There they are. And we've got 2 of the 3 numbers. There you go. So we'll divide this by that, and that concentration squared times that will be equal to that. We'll divide both sides by whatever that is. Looks like a low number, and we'll solve it mathematically. And when you do, you should get a concentration of hydrogen of 0.0377 molar. That's a couple simple setup and solve for the equilibrium constant type questions.